Welcome to our world. Welcome to WorldServe.
Welcome to Stage 0, Space Rovers. In this session, we're going to explore one of humanity's most incredible engineering achievements, machines we've sent to other worlds to explore on our behalf. So, what exactly is a space rover? A space rover is an exploration vehicle designed to move across the surface of a planet or celestial body. Unlike a stationary lander, a rover can travel to multiple sites, collect samples, and respond to new discoveries in real time, making it an incredibly versatile scientific tool. Rovers are operated from Earth using time-delayed commands, but they also carry autonomous AI to navigate hazards on their own between instructions, and they're built to last, designed to operate for months, sometimes years, in some of the harshest environments imaginable. So what do rovers do? Rovers are rolling science labs. They carry out scientific analysis using spectrometers, drills, and cameras to study soil, rocks, and atmosphere for chemical composition and signs of life. They transmit data, sending high-resolution images, videos, and telemetry back to Earth through antennas and orbital relay satellites. They map terrain in 3D using stereo cameras and LiDAR, enabling safe navigation and geological surveys. They collect samples like Perseverance, which caches rock and soil for a future return to Earth. They test new technology, like the Ingenuity helicopter and the Moxie oxygen extractor. And they monitor the environment, tracking temperature, wind, radiation, and dust storms to build a picture of a planet's climate. So how do rovers work? Let's look at how a rover actually works. It all starts with power, either solar panels or RTGs, which are radioisotope thermoelectric generators, provide continuous electricity. Onboard radiation-hardened computers handle autonomous navigation, hazard avoidance, and experiment control. For navigation, cameras combined with AI map terrain in real time. Drivers on Earth send route plans, and the rover executes them with built-in collision avoidance. Mobility is handled by a 6-wheel drive system with articulated suspension, which we'll look at in a moment. Science operations involve deploying instruments, collecting data, and transmitting results via high-frequency radio to NASA's Deep Space Network. Finally, transmission. There's a 3 to 24-minute one-way signal delay, so teams plan and uplink new commands every Martian day, known as a SOL. The rocker bogie mechanism. Now, here's one of the most elegant pieces of engineering in all of space exploration: the rocker bogie suspension system. This passive mechanical linkage distributes the rover's weight evenly across all 6 wheels without needing any springs or active components. It can climb over rocks as tall as the wheel's diameter. A differential bar across the top keeps the rover body tilted no more than half the terrain angle, protecting sensitive instruments. And if one wheel stalls or fails, the remaining 5 keep the rover moving and steerable. Simple, robust, and brilliant. Powering a rover. Rovers operate millions of kilometers from the nearest power outlet, so their power systems have to be incredibly reliable. 2 technologies have proven themselves. Solar panels used on rovers like Sojourner, Spirit, Opportunity, and India's Pragyan are lightweight and renewable. The downside? Dust can accumulate and reduce efficiency, and they don't work well in polar darkness or on outer planets. RTGs, or radioisotope thermoelectric generators, are used on Curiosity and Perseverance. They generate electricity from the heat of decaying plutonium-238, providing continuous power day and night in all weather for decades. The trade-off is weight and the strict safety protocols needed for radioactive fuel. Science instruments on board. Rovers carry a remarkable suite of scientific instruments. The mast cam and navigation cameras provide high-resolution stereo images for navigation and geology. LIBS, the laser-induced breakdown spectrometer, fires a laser at rocks up to 7 meters away and analyzes the plasma flash to identify elemental composition. APXS uses alpha particles to measure elemental abundances in rocks and soil. The weather station tracks wind, temperature, humidity, radiation, and pressure every sol. The robotic arm and drill can reach 2 meters and drill 7 centimeters into rock for fresh, unweathered samples. And ground-penetrating radar sends radio pulses underground to reveal subsurface layers and potentially ice. Chandrayaan 3. Now let's talk about a mission that made history and one that's especially close to home. Chandrayaan 3 was launched on July 14, 2023 from Sriharikota, and on August 23, 2023, it landed at a location now named Shiv Shakti Point at the lunar South Pole. The Pragyan rover, whose name means wisdom in Sanskrit, weighs just 26 kilograms and moved at about 1 centimeter per second. It was powered by a 50-watt solar panel and designed to operate for 1 lunar day, which is about 14 Earth days. India became the first nation ever to land at the lunar South Pole, a region suspected to harbor water ice, and only the 4th space agency in history to achieve a soft moon landing. Pragyan's APXS instrument detected sulfur, aluminium, calcium, iron, and titanium in the lunar soil. Its LIBS instrument further characterized the geology using laser spectroscopy, a truly landmark achievement for ISRO and for India. Notable space rovers. Let's put the history in perspective. In 1970, the Soviet Union's Lunokhod 1 became the first rover on another world. In 1997, NASA's Sojourner proved the concept on Mars. Opportunity launched in 2004 and went on to traverse 45 kilometers over 15 years. Curiosity, landing in 2012, confirmed that ancient Mars once had habitable conditions. Perseverance arrived in 2021, caching samples and deploying the Ingenuity helicopter. And in 2023, India's Pragyan became the first rover at the lunar South Pole. The future rolls forward. Rovers are humanity's eyes, ears, and hands on distant worlds. And the story is far from over. Upcoming rovers will search for biosignatures and cache samples for return to Earth. Crewed Mars missions will rely on rover-derived technology for surface operations. Lunar rovers will scout polar ice deposits to support future human habitation. And India's Chandrayaan 4, along with ESA's Prospect mission, will build directly on the legacy of Pragyan. The future rolls forward. And now, it's your turn. Introducing the C3 rover by WorldServe. You'll be assembling a complete rover using structural parts, stickers, and graphic sheets to make it your own. Inside, you'll build the payload and motor control circuitry. Your payload board carries 2 sensors for temperature, humidity, pressure, and absolute pressure, an obstacle detection sensor, and an RF transceiver for wireless communication. You'll also assemble a ground station. Using a joystick and radio communication, you'll be able to drive your rover in any direction and receive live sensor data and obstacle alerts wirelessly. The course is divided into stages, mirroring exactly how real space missions are developed and validated. Up next, let's unbox the RoboX C3 rover kit. We hope this presentation was helpful. Did you know you can own your very own C3 rover kit? Head to worldserve.in/RoboX for more information. We have other varieties of robotic kits as well. Please do like and subscribe. Thank you for your support.